Hello everyone, let's look at Leetcode question 750, number of corner rectangles. Given an m by n integer matrix grid where each entry is only 0 or 1, return the number of corner rectangles. A corner rectangle is 4 distinct ones on the grid that forms an axis-aligned rectangle. Note that only the corners need to have the value 1. Also, all 4 ones must be distinct. You may ask, what is an axis-aligned rectangle? Well, it is one which the edges are parallel to the coordinate axes, so up and down and side to side. Before looking at the examples, let's look at the constraints. So m will be grid.length, this is the column length, n equals grid.i.length, this is the row length. I will be less than or equal to m, n will be less than or equal to 200. Grid at ij is either the value 0 or 1. The number of ones in the grid will be between the range 1 and 6,000. Okay, let's look at the examples. Alright, so first let's run through the code and then we'll check out an example. First we define answer and the counter. Next we define n to be the length of grid 0. This is the length of the rows. And then we loop through all the rows in the grid. After we've done this, we enumerate the row and index every single cell of the current row. If the cell value is 1, we then loop through the remaining cells of that row, and we check if there is another cell value equal to 1. If this is the case, then we add to the answer the counter at location ij, and we increment the counter by 1 for the correct rectangle count. Initially, we had answer at 0, and then we finally return answer as our final number of correct corner rectangles. Okay, let's look at this first example. Okay then, to solve this problem, we loop through every single row and check if there are 2 ones at least. So we see in the first row, looping through, C1 is equal to 1. Therefore, we go to the next loop for j in range I plus 1 all the way to n. So the end of the row, we find another 1. If there is another 1, which there is, we add this to the answer for count at ij. Notice that count ij currently doesn't have this in it. This is because it will allow us to add the correct amount of correct corner rectangles by putting answer before the counter. So answer is incremented by 0, but counter has the values now of, so this is 0 and 3, so it is 0, 3, and the counter is 1. Then if we once more find that there is a row with 0, 3, so for example here, the counter would be 1 when answer would be incremented by 1, and then the counter would become 2 afterward. But that is not the case for this example. Let's just loop to the next row. Okay, in the next row, we see that we have 2 ones, and this becomes, they are at index 0, 1, 2, and 4, so 2 and 4 has the value 1. Note that answer is still equal to 0 because of the reasoning we just mentioned. Next row, please. 0, 0, 0, 1. There is no other 1s here, so the counter won't even receive these ij values. And then the final row, we have 1 and 1 and 1, 3 ones. Okay, let's go through it. So, as we said, we loop through every value in this row, starting with the first one. C1 is 1. Okay. This means that we can move to the next values for j in range I plus 1 to n. So we see another 1 value. It is at location index 2. So this becomes 0, 2 into the counting counter object. And then we go to the next iteration and see that there is another 1. Okay, we see that this is at location 0, 1, 2, 2, 4. Notice that there is already a 2, 4 in the counter set, so we simply add 1 to 2 and increment answer by 1. And this is our final answer. Because there are no other values that have the value of 2, it is just 1 for 0 and 3 and 0 and 2, but 2, 4 has 2, which is these 4 values right here. Okay? So in this example, we have returned 1. There is one correct corner rectangle. Now let's move to the next example. All right, let's see if this solution works. And it does work. Very nice. So what is the time complexity of this? So there's a lot of for loops, and the time complexity of this code then is O of n squared, where n is the length of each row of the grid. This is because there are 2 nested loops, one iterating over each row and the other iterating over each element in the row. The inner loop has a range of size n, so the overall time complexity is O n squared. The space complexity is also O n squared, and this is because the counter object count stores the number of pair indices where the row I and row j are both 1. The number of unique pairs of indices at most is n squared, so the space complexity is O n squared. Thank you so much for watching this video. Hope to see you next time.